All right, so let's. This is a piecewise function, and piecewise functions can be difficult. But I have a little trick that I use. So basically, we have to figure out. We have to graph this. You guys can find the limit. It's just you have to graph it. So now to graph it, let me get some graph paper because we want it to look kind of nice. So to graph this thing, I've got to graph two separate functions, and those two separate functions are no fun because you don't know when to stop and when to start, and that's the problem with graphing piecewise functions. You're going to have to kind of do it by hand. And so let me write these two down. So my f of x is equal to 3x minus 1 only when x is less than or equal to 1, and then minus 3x plus 5 only when x is greater than 1. So now here's what I'm going to do. I've drawn my little graph like this. The first thing I'm going to do is I'm going to graph I got some fancy stuff here. Let me clear this out. So the first graph that I'm going to graph is going to be the 3x minus 1. So I'm going to say 3x minus 1. But now that's only for values less than or equal to 1. So now before I hit enter, well, I'm going to hit enter, but I'm going to set my window. What is my upper boundary for that? Well, my upper boundary is 1. So I'm going to go from -6 to 1. And then the y value I don't really care about too much. So I'm going to hit graph. And so that's kind of what my line looks like. So when x is less than 1, that's kind of what it looks like. And you know what? Maybe I'm going to zoom out and maybe look at the y values a little differently. I'm going to change my y minimum to like -5, okay? And let's graph this. And so what it looks like is if I hit trace and I put x equals 1, my y value equals 2. So if I go x1, y2, I'll have a point here. And it looks like when x equals 0, y equals -1. Then it makes sense because I have a slope of 3. So now what I'm going to do is because this is included, I'm going to have a closed circle here, and I'm going to draw my line like that, okay, with a closed circle right here. Now what I'm going to do for the next part of the graph is I'm going to come in and I'm going to change my function to -3x plus 5. But now I'm going to change my window because I'm interested in when x is greater than 1. So I'm going to let my minimum value for x be 1. And I'm going to, I don't know, make my max like 6. And now I'm going to graph that. And so here, what I'm going to do is I'm going to hit trace. And since my boundary is 1, I'm going to put 1. And it should be 2. But it's an open circle. And so to represent that, it's the same point, but it's an open circle. It's an open circle because there is no equal sign in the inequality. So I have an open circle at 1, 2. Then I'm going to figure out another point. So if I let x equal 1, how about if we let x equal 2? That's -1. So when x equals 2, I've got a -1 here. So now I'm going to connect those 2 points. And I've sketched that. So that's my piecewise function. Okay? That's my piecewise function. Any questions up to this point? Because this is what's hard about it. Okay, so now that I know that that's my piecewise function, let's go back to the test and see what they're asking us. what is the limit of the left-hand side and the right-hand side when d equals 1? Well, if I look at my graph, what is the limit when d equals 1? Well, what they're saying is when I approach, in other words, what is the limit of f of x as x approaches d from negative infinity? So that means I'm going to come here, and we're looking at d equals 1. So what is the y value as we approach that? 2. Then the next thing they're asking us is what is the limit of f of x as x approaches d from positive infinity, right? From this direction. So I'm going to come in this way along the graph, and as I get closer and closer to x equals 1, what does that approach? 2. Now, does the limit exist? I have the left-hand side equaling the right-hand side. Does the two-sided limit exist? Well, if I click on C, it says yes. Correct job. What is that limit? 2 and 2. What were the questions? There was A, B, C. Oh, I forgot to...
Why does yours say -1 and ours says 2 3 times?
Because A is above it.
Because it's 2, 2, 2.
Wait, what? Yeah.
It's, yeah, see that? 2, 2, 2, 2, 2.
Oh.
Wait.
Did I say -1 out loud?
No, I was looking.
Okay.
I got confused.
Back, please.
To this?
Yeah. Wait, how? Oh, because when it's at 1, it's 2 and 2. Okay.
And so since the left-hand side equals the right-hand side, then the two-sided limit, which is part C, is going to be the same value. In other words, because those two equal, the limit of f of x as x approaches d from both sides is going to be 2, because this was 2 and this was 2. So as we approach from the left and the right, they both equal 2, so then the two-sided limit has to be the same.
So if they approach from both sides and it's not the same, is that when it does not exist?
The two-sided limit doesn't exist, yeah. And remember, limits are a study of behavior. What is the graph approaching as we get really, really close? Not what is the value, or is it, you know, like, you can, that's why we have a two-sided limit and a one-sided limit, because there are situations where we may only be able to take a one-sided limit, right? But this is a qualifier for whether or not something is different. By the way, is this differentiable at x equals 1?
What does that mean again?
You could take the derivative of it. Is it? Yes or no? Can you take the derivative of this function at x equals 1?
If you really believe.
If you really believe, no. The answer is no. Why?
It's a corner.
It's a corner. Very good. Yep, it's a corner.